This video will cover section 5.3 homework, Piecewise linear functions. If you find this video helpful, please give it a like and subscribe to see more videos like this in the future. Let's get started. Before I start going over problems, I want to explain a bit about what piecewise functions are. Piecewise functions are functions that are pieced together from two or more expressions, hence the name. Next to each expression in the piecewise function, it will state the domain that uses that expression. For example, on question 1, there are two expressions used to create f of x. I can see that it says 3x plus 1 if x is less than 0. This means that if I want to evaluate this function for an x value that is less than 0, I need to use this first expression. It also says 3x plus 2 if x is greater than or equal to 0. This means that if I use an x value that is greater than or equal to 0, I need to use the second expression. Question 1 wants me to use the piecewise function to calculate several values. If I look at the first part, it wants me to calculate f of negative 1. This means I need to plug in negative 1 for x. Since negative 1 is less than 0, I'll use the first expression and can set it up as 3 times negative 1 plus 1, which will give me negative 3 plus 1, which is negative 2. Next is f of 0, which means the next x value is 0. Since 0 is equal to 0, I'll use the second expression. I'll set that up as 3 times 0 plus 2, which will give me 0 plus 2, which is equal to 2. Last, I have f of 3, which gives me an x value of 3. Since 3 is greater than or equal to 0, I'll use the second expression. I'll set that up as 3 times 3 plus 2, which will give me 9 plus 2, which is equal to 11. Question 2 says, a cell phone company uses the function below to determine the cost C in dollars for G gigabytes of data, and gives me the piecewise function C that equals 50 if 0 is less than G is less than 3, and that equals 15G plus 5 if G is greater than or equal to 3. It wants me to calculate the cost for 1.5 gigabytes of data and the cost for 7 gigabytes of data. To find C of 1.5, I'll use the G value of 1.5. Since 1.5 is between 0 and 3, I'll use the top expression. Since there is no G value in this expression, the function will just be 50. To find C of 7, I'll use the G value of 7. Since 7 is greater than 3, I'll use the bottom expression. I'll plug in 7 for G and get 15 times 7 plus 5, which will simplify to 105 plus 5, which equals 110. Question 3 wants me to set up the piecewise function this time. It says a museum charges $6 per person for a guided tour with a group of 1 to 12 people, or a fixed $78 fee for a group of 13 or more people. Write a function relating the number of people N to the cost C. Since this is a word problem, I'm going to break it down by listing any numbers and what they measure, and any variables and what they represent. The numbers I see are 6, 1, 12, 78, and 13. 6 is the cost per person when the group is between 1 and 12. And 78 is a fixed fee for a group of 13 or more. The variables are N and C. N is the number of people, and C is the cost. Let's set up the domain first. Based on the word problem, I can separate the domain based on either 12 or 13. I can only use one number to separate the domain, and because the second domain says n is greater than or equal to, and the word problem said 13 or more people, I'll use 13 for both domain restrictions. Now to set up the expressions. If it is less than 13 people, the museum charges $6 per person. Remember that per is a keyword that means multiply, and that n is the variable for the number of people. That will make the first expression 6 times n. Because 78 is a fixed rate used for any number of people over 13, the second expression will just be 78. Question 4 also wants me to set up a piecewise function. It says shipping company IPS has shipping rates that are a function of the weight of the parcel. For packages weighing less than or equal to 7 pounds, they charge $1.5 per pound. For packages weighing between 7 and 11 pounds, they charge $2 per pound. If packages weigh 11 pounds or more, they charge $2.5 per pound. IPS refuses to ship any parcel weighing more than 54 pounds. There's also a flat fee of $2.5 for all deliveries and an additional fee of $5 for all deliveries weighing 11 pounds or more. Complete the following description of a piecewise function so that it describes the shipping cost C of x in dollars as a function of the weight x in pounds. Just like on question 3, I'll start by breaking down the word problem by listing any numbers and what they measure, and any variables and what they represent. The numbers I see are 7, 1.5, 7, 11, 2, 11, 2.5, 54, 2.5, 5, and 11. It says that for packages less than or equal to 7 pounds, it's 1.5 per pound. Between 7 and 11 pounds, it's $2 per pound. And 11 or more pounds is 2.5 per pound. they won't ship anything over 54 pounds. There's a flat fee of 2.5 for all deliveries. There's also an additional $5 for all deliveries over 11 pounds. The variables I see are C of X and X. C of X is the shipping cost. And X is the weight in pounds. I can see that the domain restrictions have already been set up for me. The first expression is from 0 is less than X is less than or equal to 7. The second expression is from 7 is less than X is less than 11. And the third is from 11 is less than or equal to X is less than or equal to 54. Let's go through each of the number clues one at a time. Remember that per is a keyword that means multiply. Less than 7 pounds is 1.5 per pound. Since per means multiply and X is the weight in pounds, that will be 1.5X for the first expression. From 7 to 11 pounds, it's $2 per pound. That will give me 2X for the second expression. Greater than 11 is 2.5 per pound, which will give me 2.5X for the third expression. I don't have to worry about the nothing over 54 pounds clue because it was already applied for us in the third domain restriction. It also says that there is a flat fee of $2.5 for all deliveries. Flat fee means I need to add 2.5 to all deliveries. So I'll add 2.5 to all three expressions. The last number clue says that there is an additional fee of $5 for all deliveries over 11 pounds. The only expression that has a domain that is over 11 is the third expression. So I'll add 5 to that expression as well. Now I need to make sure each expression is fully simplified. I have 1.5x plus 2.5 for the first expression, 2x plus 2.5 for the second expression, and 2.5x plus 7.5 for the third expression. The last part of this problem says, how much does it cost to ship a package weighing 7 pounds with IPS? 7 pounds will make 7 an X value. Since the first domain restriction is 0 is less than X is less than or equal to 7, I'll use the first expression because 7 is equal to 7. If I plug in 7 for X, I'll have 1.5 times 7 plus 2.5, which will give me 10.5 plus 2.5, which equals 13. Question 5 wants me to graph a piecewise function. Because both expressions in this piecewise function are linear and graphed with a straight line, the easiest way to do this is to evaluate each expression at the edges of its domain restriction and to use the slope and/or y-intercept to get a second point. It sounds more complicated than it is. My function uses x minus 5 if x is less than or equal to 3, and negative x if x is greater than 3. This means that it switches from the top expression to the bottom expression when x equals 3. The first step will be to find out what each expression equals when x equals 3. For the top expression, I'll set it up as 3 minus 5, which will give me negative 2. So the top expression ends at the coordinates 3, negative 2. The bottom expression is just set up as negative 3. So it starts at the coordinates 3, negative 3. Now I can place 2 dots on the graph. However, I have to figure out whether to use an open or solid circle. I can determine that by looking at the domain restriction. If x can be equal to 3, I'll use a solid circle. If x cannot be equal to 3, I'll use an open circle. For the top expression, I can see that because the inequality symbol has a line under it, x can be equal to 3. So I'll use a solid circle to plot 3, negative 2. For the bottom expression, I can see that there is no line under the inequality symbol, so x cannot equal 3, and I will use an open circle to plot 3, negative 3. Because this is a function and must pass the vertical line test, I cannot have 2 solid circles in a vertical line with each other. If you have 2 solid circles in a vertical line with each other, you will need to double check the domain restrictions of your function. Now I can look at the slope and/or y-intercept to find a second point for each expression so I can finish the graph. For the top expression, because it has the domain restriction x is less than or equal to 3, it includes x equals 0, which is on the y-axis. This means I can use the y-intercept of the top expression as a second point. Remember that the y-intercept is the number not next to x. Since negative 5 is not next to x, it is the y-intercept, and I can plot the line of the top expression using the solid circle at 3, negative 2, and the y-intercept of 0, negative 5. For the bottom expression, because it has the domain restriction x is greater than 3, it does not include x equals 0, so I can't use its y-intercept to find a second point. Instead, I can use the slope. Remember that the slope is the number in front of x. Since there's only a negative symbol in front of x, I can assume that there is a negative 1 in front of it for the slope. Because the slope is negative, I need to move down and to the right. To find the rise and run, I'll place a 1 underneath it and get negative 1 over 1, making both the rise and the run 1. So to find the second dot, I'll start at the open circle of 3, negative 3, and move down 1 square and right 1 square to place the second dot. Now I need to state my domain and range in interval notation. Remember that lines at the edge of the graph will continue in that direction forever, because the left side will continue going down and left, the right side will continue going down and right, and it jumps straight from the first expression to the second expression without skipping any x values. My domain will be all real numbers, which is from negative infinity to positive infinity, and I can enter it as parentheses negative 00, comma 00, close parenthesis. For the range, because both sides will continue going down forever, there is no limit going down, meaning my range starts at negative infinity. However, the highest y value that is used on the graph is at the solid circle where y equals negative 2, making my range parentheses negative 00, comma negative 2 bracket. Question 6 also wants me to graph a piecewise function. Just like on question 5, both expressions in this piecewise function are linear and graphed with a straight line. This means that the easiest way to graph this is to evaluate each expression at the edges of its domain restriction and to use the slope and/or y-intercept to get a second point. My function uses 1.5x plus 0.5 if 1 is less than or equal to x is less than or equal to 13, and 0 if x is greater than or equal to 14. This means that the domain goes from 1 to 13, then skips to 14 and goes to infinity. To graph the first expression, I'll evaluate for the first and last domain values that use it to get coordinates that I can graph. If I plug in 1 for x, I'll get 1.5 times 1 plus 0.5, which equals 2. So I can place the first dot at 1, 2. Since the domain restriction for the top expression can be equal to 1, it will be a solid circle. Now I can plug in 13 for the second x value to find my second coordinate pair. If I set that up, I'll have 1.5 times 13 plus 0.5, which equals 20. So I can place a second dot at 13, 20. Because the domain restriction for the top expression can be equal to 13, it will be a solid circle. Now I can connect the two dots for the first expression with the line segment. Because the bottom expression is just 0, when I evaluate it for the x value of 14, I don't need to plug in any values. It will always equal 0, giving me the coordinates of 14, 0 for the next dot. Since the domain restriction for the bottom can be equal to 14, I'll use a solid circle. Because this expression is just a single number, I can graph the line for it as a flat horizontal line. Because the domain is x is greater than or equal to 14, the line will continue to the right of the dot at 14, 0. Question 7 wants me to find the domain and range for the graph and write them in interval notation. Since the line ends in points, I only need to worry about the x and y values I can see on the graph. Remember that domain is the x values, and range is the y values. Also remember, if a line ends in an open circle or continues off the end of the graph, the interval notation for that end is written with the parentheses. Otherwise, it is written with a bracket. Let's start with the domain. If I move in from the left, I can see the graph starts right here where x equals -5 and is a solid line until this point on the right where x equals 3. Both points are shown with solid dots, so I will use brackets to write the domain of -5, 3. For the range, I will start from the bottom. I can see that the line starts here where y equals 3 and continues as a solid line until it reaches this spot at the top where y equals 5. Because it starts at the bottom with a solid circle at y equals -3 and ends at the top where it touches y equals 5, I can write the range as bracket -3, 5 bracket. This concludes section 5.3 homework, Piecewise Linear Functions. If you found this video helpful, please give it a like and subscribe for more videos like this. If you have any questions, leave a comment down below or message me through Lumen or Remind. As always, remember to be safe, be smart, and try to make wise choices.